Good afternoon and a very warm welcome to one and all present here for today's TED Talk session. With us today, we have Ms. Katherine Bruce, our Senior Sustainability Consultant at AESG Dubai as a chief guest, who will be speaking on the topic of sustainability practices. The purpose of this event is to have deep and practical knowledge of sustainable practices, especially in chemical industries. And in view of this pandemic situation, sustainability is what we all should implement in our personal and professional life. This event is conducted under ACS student chapter. Now, I would like to ask Dr. Vandana Sakre to brief us about the ACS student chapter and their activities.
Thank you, Fayaz. Good afternoon, everyone. I would like to first thank Mr. Katherine, who has accepted our invitation to be as a presenter on sustainability practices. And this is our student chapter activity. Basically, we have two student chapter in the Department of Chemical Engineering, School of Engineering and IT. First is American Chemical Society, which is called as ACS, and another one is AICHE. So we are conducting this activity under ACS student chapter. The purpose of the ACS student chapter formation is to provide information solutions, which is basically in the form of having and delivering related information solutions to address the global challenges and other issues facing by the world scientific community. The other goals are empowering members and member communities by providing access to the opportunities, resources, skill training, and network to empower our members and member committees and support excellence in education. This is possible with foster the development of the innovative, relevant, effective chemistry and chemical engineering related education. And finally, we can have the communication to the society with the help of better utilization of chemistry and chemical engineering in a vital role of chemical professionals. So the activities which we usually conduct under ACS student chapter is guest lectures, invited lectures, technical sessions and webinars, students projects and webinars, and student project competitions. School contact program is one of the program which we used to conduct every year, and we used to conduct every activities related to students under student chapter activities. So today in this connection, we have sustainability practices in the industries and to be presented by Miss Katherine. So moving forward to see the presentation by her. Over to you, Fayaz. Thank you.
Thank you, ma'am. Now I would request Mr. Diego to introduce our chief guest to the audience. Over to Diego.
Okay, so our chief guest, Katherine Bruce, is a senior sustainability consultant at AESG. She holds a master's degree from the University of Cambridge in Engineering for Sustainable Development and a master's degree in chemical engineering from Heriot-Watt University UK. Katherine specializes in strategic sustainability advisory, green buildings, and health and well-being. Katherine's role integrates coordination and communication between clients, consultants, and government bodies for a range of high-profile sustainability projects, including policy planning, support for Dubai's DSM program, LEED certificate for DIFC Gate Avenue, and First Well version 2 certificate in the MENA region. Katherine has a proactive attitude and detail-oriented approach to her work. She is continuously expanding her knowledge in the field of sustainable construction and has raised her profile as an industry thought leader by actively participating in high-profile industry events and publications. In 2018, Katherine was recognized for her performance by the Middle East Consultant Awards and was awarded Rising Star of the Year. That's her bio. Over to you, Katherine, for your main part of the speech.
Brilliant. Thank you very much, Diego, for the introduction. And thank you very much for having me here today. I really appreciate having the opportunity to present to you all on a topic that's really of big interest to me and in my career so far to date. So I'm just going to share my screen. I have some slides that I'll present today, and then we'll have a question and answer session at the end of the presentation. Okay. So if you could just confirm that you can see my screen.
Yes, ma'am, we are able to.
Yeah, we are able to see.
Okay, great, thank you. So today I'll give a little bit of a background on my career in the sustainability industry, coming from an engineer, what sustainability is, and some details on sustainability in industry and what kind of tools and methods we can use in practice to help make engineering projects more sustainable. And then I'll discuss a little bit about the different career opportunities that are available to people who want to go into the sustainability world. And then, as I mentioned, we'll have some time for questions and answers at the end. So a bit about my background. I graduated in 2014 with a master's degree in chemical engineering at Heriot-Watt. And at the time, I and many of my colleagues at university were quite keen to enter the oil and gas industry. A lot of people in the university and in the area, it was quite a popular sector to go into. And I then joined Technip in Abu Dhabi as a pre-commissioning commissioning engineer, where I worked in the Prelude project, which is a large floating liquid natural gas plant currently in Australia, but at the time it was being constructed in South Korea, and had the opportunity to work during the construction of this vessel. So this is a picture in South Korea, and I spent 2 years working with Technip, where I learned a lot about the processes of integrating the operation manuals into real life practice. But during this time as an engineer, I realised that I wanted to perhaps change my career path, and a turning point for me was back in September 2015, where I landed in Singapore for a conference, and I was met by this smog. So in Indonesia, there was ongoing deforestation caused growth of palm oil trees, and the palm oil production was resulting in a large amount of smoke that was blowing over into Singapore. And for me, being able to walk around and taste the smoke and breathe in really bad air quality, I realized that humans are having such a destructive impact on our environment, and I need to try and look at different ways I could use my engineering skills make positive difference and positive impacts in the world. So after that experience, I went back and decided to apply for a master's degree in engineering for sustainable development. And I did that back in 2017. And I did an MPhil at the University of Cambridge, which was a really, really great experience. I learned so much about how sustainability could be implemented into industry, and I met a lot of engineers from all over the world that were all really passionate about making the world a better place. So it was such a positive and inspiring environment to be in. From there, I then landed in my current role with AESG, where I'm a senior sustainability consultant, and I've worked with the company for the past 3 years, mainly in the construction and built environment sector, where I help advise clients on how to make their projects more sustainable. So that could be from persuading them to integrate a grey water recycling system, or looking at the embodied footprint of their building, to the health and well-being of the residents and visitors in their projects. So I wanted to discuss a little bit about what is sustainability. It's a good question, and often I get asked this working in the sustainability industry. What exactly is the definition? Now, you're probably familiar with the Brundtland definition, so sustainable development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is quite a common definition that's used. However, sustainability is intentionally vague, and it's really vague for a good reason, because the word and term sustainability is a way to connect these global challenges like pollution, environmental damage, climate change, ecological devastation, global inequality. Sustainability is really the umbrella that kind of brings together all these global challenges, and without having such a concept, these global challenges would be competing against each other in the public domain. So the term is really a way to help describe these overarching overall challenges that we face in day-to-day society. So there's different ways people have come up of terming sustainability. You might be familiar with the 3 pillars in that first image. So that's a Venn diagram which shows the 3 pillars of economy, society and environment, and sustainability being the overlap of those 3. Probably one of the criticisms of this Venn diagram is that it kind of makes the assumption each of these 3 parameters need to be equal in order for you to achieve sustainability, which is not always the case, and not all of the 3 parameters are essentially the same size when you look at a sustainability issue. The second image there is a nested diagram, which really shows how, or recognises that humans are within a broader environment, and that economic activity is a construct of society. So that nested diagram is quite a good representation of how sustainability fits in that concept. The third image there is a donut diagram. So here you have the outer edge, which represents the natural limits of Earth, like climate change, freshwater use, land use. And then the inner circle represents the basic needs for humans to have a good quality of life. And then the gap in the middle is really the space where, the safe space, you could say, where humans should be. And that you need to keep within these limits of the outer edge and the inner edge. So there are 3 examples of how people have described sustainability, but I wanted to look at sort of the difference in 2 engineering examples of bridges. So a bridge is a crossing point from one side of the river to the other. You can see here these 2 bridges examples, one a Roman bridge from AD 106 and another an Inca grass bridge. Both have the same purpose, but both have different positives and negatives from an engineering perspective. So from an engineering, for the Roman bridge, it's long lifetime, it might be a high initial cost, but it's got a high load capacity. From the Inca grass bridge perspective, it has high stresses, high maintenance. It's a lower initial cost though, perhaps has a lower load capacity. So, you know, as engineers, we tend to look at what are the advantages and disadvantages through this engineering lens. But when we ask ourselves what is more sustainable out of these 2 bridge options, we sometimes fail to think about, well, it depends on the context. So both of these bridges actually do perform well, and it's all about the context they're designed to operate. The Roman bridge demonstrates that Romans will be a permanent figure in that time period. The Roman Empire is here to stay, whereas the Inca bridge, it helps because it's been remade on a yearly basis. It helps to glue society together, provides a purpose for the community, and adds to the social cohesion of the group. So even although they're 2 different bridges, they both have different sustainability contexts. And as engineers, one of the things we have to think about when looking through sustainability is not just the materials and the built environment, but more how do these play a role in society. So how did we get here? So we had the Industrial Revolution, which saw a big uptake in infrastructure across the world, railways, ports, roads, harbour, material. Everything here was built to help create and improve the quality of our life. But the impact of all these materials and construction was a lot of negative environmental impacts, social impacts, and economic impacts as a result. And at the time that these infrastructure was built, we perhaps weren't quite aware of what we were locking ourselves into. And it's, you know, we see technology changing very fast, but infrastructure has been around for a long time. You know, example is a road. Roads that we drive on today are quite similar to roads that people were driving on 60, 70 years ago. And the roads that we have in our societies have actually you know, restricted different types of transport to be put in place, or more sustainable forms of transport, because we already have this existing infrastructure. We can't just suddenly do away with roads and fly everywhere, as an example. So a lot of these issues of the challenges that we face today are also some of the decisions that were made in the past with regards to how our infrastructure and engineering world works. So a big aspect of sustainability as well is climate change, and you're probably very aware of the impact that burning fossil fuels is having on the environment and in the long run. If we look at how the world consumes energy, one of the reasons why I wanted to go into the built environment was because of the amount of energy used in buildings. And this isn't just the operational aspect of buildings, this is all the materials that we use to put in the buildings. So everything that all the concrete, the metal, the steel, everything that goes in that building has an embodied footprint, and that overall increases the energy consumption that's associated with buildings. So if we look at the industrial carbon emissions, so this is the carbon emissions associated with making different materials. Around 5 materials are responsible for nearly 55% of industrial carbon emissions globally, and 2 of these materials, steel and cement, are used significantly in the construction industry. And the embodied emissions associated with steel and cement, for example, if we look at the Burj Khalifa, there's around 4 tons of carbon dioxide per meter squared, and you compare that to a small villa in Dubai, it's about 10 times higher. So there's a big challenge around how can we reduce embodied footprint of steel and cement that overall reduces the CO2 footprint. So when we consider sustainability, taking a step back and looking at what globally countries are doing, there was the climate change agreement back in 2015 where they came up with the Sustainable Development Goals, and these are a set of 17 goals that help to address some of the issues that I mentioned before that have engineering infrastructure has faced. So inequality, climate change, the ecosystem preservation, to name a few. And each of these goals have a set of indicators, and every country in the world is working towards trying to achieve the indicators in the Sustainable Development Goals. So these goals set out the indicators, and then within each country, the innovation, the creativity, private public sector, everybody has a responsibility to try and work towards achieving these goals. So how does that then feed into the engineering world? So I wanted to discuss different tools that engineers can use in their work, and particularly for graduates when they enter the field of engineering, what kind of tools can they use themselves in their industry to make their processes more sustainable? So there are quite a lot of different ways that we can find out what is more sustainable, how processes are more sustainable, and there's different tools. And there's a couple of examples here. We've got systems thinking, eco-auditing, multi-criteria decision-making, ecosystem services valuation, agent-based modelling. These are just a few tools, but the one I want to talk about today is life cycle analysis as a sustainability practice that can be used across so many different sectors, and it's a really great method for engineers to consider how they can implement this in their engineering process, whether that is in retail, in pharmaceuticals, in the built environment. This method can be used in a lot of different sectors. So it's a cradle to grave approach. So that means we're looking at sustainability through the full holistic lens of a material or a process, right from its birth to the end of its life. So the full life cycle is considered in the life cycle analysis. It helps us to understand different inputs and outputs and how they impact the environment, in particular environmental impacts like the amount of CO2 that's produced, how it's contributing towards polluting the water streams, how it may be contributing towards acidification and different topics. So it helps engineers to answer those questions. What if we do this process in a different way? How will that impact the sustainability of the process? So the first life cycle analysis for Coca-Cola was conducted back in 1969, and it was used to look at the difference between glass and bottle production. And then perhaps you might think that glass production bottles maybe is a more sustainable approach, since the use of plastics and single-use plastics has been quite prominent in the news recently. But contrary to that belief, actually they found that plastic bottles were more sustainable than the glass bottles when they conducted their full life cycle assessment. So the life cycle analysis firstly looks at the boundary of the process. So whatever process you may be looking at, whether it's a chemical production, whether that's in oil and gas, or it's making, designing and building a building, the first step is to create that project boundary. So where are the inputs and the outputs? And what are you considering within that project boundary in terms of what sustainability assessment you want to complete? So the life cycle assessment is product orientated. It's scientific because it considers the data that's already been collected. So there's a number of tools that you can use to assess the different sustainability impacts of a range of operations and material. And it helps to look at the whole process and not just shifting one problem to another. So a classic example is petrol cars versus electric cars. Which one's more sustainable? Petrol cars, maybe if you reduce the use of them, you might reduce emissions, but pushing everything onto electric cars actually increases the use of electricity, which upstream may increase emissions associated with producing that electricity. Similar with, say, window frames, there's two different types of material that could be used. Which one is more sustainable to be produced? Or maybe if it's chemical waste, where can we dispose the chemical waste, looking at the different countries and the carbon footprints associated with each of the disposal options. So it's a great way to try and make a decision in an engineering process, which of the processes would be more sustainable, and get a better picture of what the impacts will be. So in process engineering, it's a great tool to assess the supply chain. It can help determine and enhance the material selection, and it can also be used to quantify the impact of end-of-life options of different materials. It can also be used as a way to make policies and make key decisions and have a comparison of different processing alternatives that may be considered. So what are the main steps in conducting a life cycle assessment? So probably 4 main key steps. The first is to identify what is the purpose of the LCA, what problem is the engineer trying to solve. Perhaps they're looking at which material they should use in a process, or where are there inefficiencies in their process where they can reduce the environmental impacts. So it's really important to try and understand what question are you asking and what answer are you looking for, and then set the boundaries. So what's within the control of your process that you can have an influence on, and what things are outside of your control that you might identify have a negative environmental impact, but you're limited in your control to influence them. The second step would be then to start gathering the data on the process that you're assessing. So looking at each stage of the material's life cycle, from the preparation, extraction of resources to the use of that material to its end of life, understanding at each stage where there's perhaps waste produced, where there's an impact on the environment. Once you get that data, you can then assess at each stage of the life cycle which stages have the biggest impact and where can we make the biggest changes. And then finally, once you've made that assessment, you can then summarize what are the findings from your study and where are the gaps that you've identified in the process. So it's particularly important that you're clear on where you've made any assumptions, where data has been missing, or where any estimations have been determined without enough evidence or enough data, to make sure that your results and your analysis doesn't have any bias. So going into a little bit more detail, I mentioned about the scope issues. So this is, what are the drivers for the change? Why are you conducting this life cycle assessment? What is it that you want to figure out or improve in the process? And then that could be, maybe you want to increase the profitability of the material, but make it more environmentally friendly, or perhaps it's assessing a different kind of new technology, or improving environmental performance. Then you have to map the full life cycle of that process. So in this case, we have ethylene, natural gas, and ethylene being used to produce polymer, and we have the different stages of that process flow, and at each stage we need to identify where is energy being consumed, where is there any environmental impact. And then compile all the inventory. So usually we do this on a say energy per ton that's used to create the product. So you need to have some common units across the life cycle so that you can make a like-for-like comparison between each of the different stages in the process. And then you can use a lot of different computer software and simulations that are full of life cycle assessment data already, and that can be used to plug in your data and generate different results. So this is an example of the energy that's being consumed in HDPE production, and you can see the different flow rates of the energy consumption at each level. And then you can do the same for another supply chain flow process to compare directly between the two, which one has a less of an impact. So when we talk about these impacts, you're probably familiar with CO2 as one of the environmental impacts, but there's a number of different impacts listed here that you can also use an LCA to assess against. So some of them look at acidification, like from acid rain, fossil fuel depletion, solid waste, radioactivity, and resource extraction, to name a few. And you can actually assess and rank all the different environmental issues through the process. And typically there's a weighting that you look at when you make the final decision. Climate change is often the highest weighted environmental issue, with water abstraction being the second. And then depending on the needs and the outcome of the LCA, you can look at adding in different environmental issues that you want to assess. So I just want to briefly go through a case study of an example from the UK, where there's an environmental assessment conducted of a UK sewer system, and the aim of the study was to look at what material type is the best to be used that has the least impact on the environment. So similar to, as I mentioned before, the project defined the scope, the goals, they produced their flowchart and collected data on the different materials that they wanted to assess against. And then they conducted the life cycle analysis and classified the different impacts that they have, and then generated a report which analysed the different environmental impacts and provided a recommendation of which material would have the least environmental impact. So the different stages that they considered were looking at the all the raw materials and then converting them into a pipe through the manufacturing process, the transportation of the materials to site, and the construction, maintenance and decommissioning, and ultimately the final disposal of those systems. So that's that cradle to grave approach that I mentioned. And this is a diagram that explains the different operations on each. So when they plugged in the numbers into their tool, this is the results that they got. This is a list of the different environmental impacts for each of those materials. And they found that concrete scored the least across these different environmental impacts. So the concrete is in red in this image here, in terms of energy, chemical waste, greenhouse effect, acidification, and so on. However, it's important to note here that this case study was actually commissioned by the British Society for Concrete. So you can see already that they have some bias towards the materials that ultimately get recommended. And there was a lot of criticisms from different governing bodies and private sectors within the UK on they didn't fully consider the different aspects of the life cycle. So they didn't look at, for example, impact of leakage in the pipes, or different sealing in the piping systems, or what would happen if there are cracks on the pipes. And plastics were also not considered in full detail because there wasn't any plastic pipe organisations consulted during the process. So you can see quite quickly that despite doing quite a thorough assessment, there are gaps in this case study where if they had reviewed different aspects of this, perhaps it might have generated a different result. So these are some examples of plastics as plastic piping and how that could be used in as an alternative to concrete. And this was a list of some of the advantage that plastic pipes had that were not recognised in their life cycle assessment. The reason why I'm going into the sort of criticisms and the differences is that we need to think when we do an LCA that we shouldn't consider that as a final answer. Life cycle assessments are a way to inform a design team or an engineering team of a possible solution, but they're not always covering the full story. So it's important to consider where there could be biases in the calculations that have been conducted, and an engineer should revisit if there has been any assumptions. How much impact do they have on the overall calculation? And also it's important to look at the boundaries within the life cycle assessment to make sure that those boundaries are really clearly defined. And then all stakeholders should be involved in this study. So if you're looking at, for example, producing a new kind of plastic or a new chemical, you need to consult the different stakeholders from different backgrounds that maybe have an influence or perhaps have data that could be used to enhance the study. So that's a little bit about a life cycle assessment. As mentioned, it's a really useful tool. It's not the answer in every time, but it should be used as a way to inform engineering teams alongside different other tools that can be helped to give a better picture of the sustainability of the different process. So I wanted to also touch upon career opportunities and how, if anyone's interested to work in sustainability, what sort of opportunities or career paths that they may have. Firstly, like, sustainability is such a huge topic that actually any sector that you can think of will need some form of a sustainability either consultant or engineer or specialist, because sustainability is one of those topics that really captures every single activity that humans are conducting, and anything that we do, that we make, that we produce needs to have a sustainability lens to look through and make sure that it's being produced without impacting the environment in a negative way. So some of the 4 key routes paths for sustainability that I've picked out here, and this is by no means an exhaustive list, but we have an engineering or technical specialist role. So these are people who work, if you're going from a chemical engineering graduate, perhaps it's in process engineering, where you're responsible for the process of a new material, a new chemical, or you could be specialising in energy management, so looking at how to reduce the energy consumption in assets and buildings and in projects, or environmental management, where you could be assessing the environmental impacts of a construction site, for example. So people working in these fields tend to be quite site-based, are often at the forefront of the actual processes itself, and are quite involved in the day-to-day operations of a product supply chain, for example. Or another aspect is consulting. So that's currently the role I'm in, where you consult with clients on how to make their process more sustainable. That could be from a technical perspective, where you're really adding a more technical expertise across a different range of topics, or perhaps from a business management perspective, so management consulting and how to effectively make processes within the business management more sustainable. Another aspect is research and development. So within the private sector, that could be within like a pharmaceutical company, or in public sector, government, PhD students, or staying on in the university itself to become a research associate and researching different sustainability processes or materials that have a more sustainable impact than others. Or another stream in sustainability would be entrepreneurship. So perhaps you have an idea where you want to take it to life, and it's something that will help either reduce energy or reduce environmental impacts in some form and make things a more sustainable process. And there's a lot of different grants nowadays where entrepreneurs can get access to funding to help start up their business model and take that forward. So there are just a couple of examples on that. And that brings me to the end of my presentation. I know there's quite a lot to digest. I'm very happy to answer any questions that you may have, and thanks again for having me today.
Thank you, ma'am, for a very informative talk on sustainable practices. Now I would request Shubha ma'am to proceed with the Q&A session. Over to ma'am.
Hello, good afternoon. The first question I would like to ask from my side. Ma'am, can we go in for sustainability studies for bioprocess industries like
So was that question around sustainability in bioprocess and engineering?
Yeah, bioprocess engineering.
Yeah, so with with bioprocessing and engineering, it really depends on the energy consumption that you're using to make the process. So I know a lot of bioprocessing can be utilized at lower temperatures because you have enzymes that are utilized to reduce the reaction temperature of the chemical engineering process. So that's bioprocessing in itself actually has a improved sustainability impact because you're utilizing these enzymes that can reduce the operation temperature of the process. And then you can look at, well, do you want to make that a continuous flow or a batch reactor? what are the sustainability implications of the different processes. Perhaps with a batch reactor, you might have more waste that's produced that you might have to process. Maybe a continuous reaction can have less waste depending on the operation of the process. So it's a case-by-case basis. You know, I can give an example of when I was at university and I was making polymers, and I had to assess the environmental impact of using microwaves to produce polymers. So the main challenge was the microwave was in a batch reactor. You put the polymers in and you get you put the chemicals in, you get the polymer out, but it was a long process. And with the microwave, we had a continuous microwave as well, where you could actually react the materials at a much faster speed with a lower energy. So it's a case-by-case basis, but yeah, there's different options we can look into.
Okay, thank you. The session is open for questions, so students can please put up their questions in the question and answer section. All the participants.
In the meantime, I want to ask, like undergraduate chemical engineering students, how can they start working on sustainability?
I think if you're an undergraduate now and you want to get interested in sustainability, it's a great time to look at it from in your design projects, or if you have a thesis or an end of year project that you need to do, to try and look at it through a sustainability lens. So whether your research project, whatever chemical engineering process that you're looking at, try and start to consider what the environmental and sustainability implications that process might have, and include that in your research. So perhaps include a section in your design report on these are some sustainability implications. So you already start to get a feel of looking at things through a sustainability lens. And it also helps when you want to go into industry. If you have a research project or a design project, I'm not sure what your course offers, but either or, you're already considering it during your early years, and then in your CV you can have that your end of year project was looking at the sustainability of this process or so on. So it's good to get interested in it in an early stage and have that sustainability lens.
So how technology is going to help students, like any software related, because if they are going to use any research project related to sustainability, say for example, sustainable water system or sustainable product development or sustainable technology development related to chemical engineering applications, how softwares are helping them in, like what kind of software they should look after?
Okay, I think for chemical engineering processes, since I've been more focused on the built environment, I'm probably not as across all the different softwares in chemical engineering, but I do know for the students who are interested in energy management, we use a software called IES, which is a tool that we can assess the predicted energy consumption of different buildings. And we input the input parameters like the set points of the temperatures, the envelope of the building, the thermal resistance, conductivity of different parameters on that building, and it basically generates a model that assesses how much cooling would be used in a year, how much heating would be used in a year, and then you can make improvements to that building, changing the efficiency of HVAC systems, for example, and that can then determine how much energy savings you can get. So these are models that we use in built environment. In the sustainable like process engineering sector, we used Aspen HYSYS quite often for processes in the oil and gas industry, and I think I'm not too familiar with using that from a sustainability perspective, but I'm sure there's elements within that where you could look at making improvements to process flow and efficiency.
Yeah, thank you.
We have the next question from Dr. Simi. For sustainable projects, does UAE government provide any initiatives, incentives?
It's case by case basis. So we did work with the government on looking at creating a building rating scheme where, depending on the sustainability performance of that building, they would get awarded or ranked like an A star, B star, C star. So this was a project that started a couple of years ago, which it's still ongoing in the background, and perhaps in the next couple of years that would be launched. So buildings actually are incentivized to reduce their energy consumption through having a ranking or a rating. There is a sustainability awards, I believe. I can't remember the name of the initiative, but I've definitely seen something recently where if you have a sustainability idea or a startup, that you can apply to an award online. I think it might be the Zayed Prize, but perhaps I've got it wrong. But there's definitely, the government definitely have a lot of programs and awards out there. You just need to check on LinkedIn or check on the government pages, see what kind of activities and incentives that they have. But yeah, having support from the government is great in these times, especially with sustainability.
Okay. The next question is from Vijay. He feels that we have inventions coming up every now and then. So keeping sustainability in mind, is it possible that reusing of any type of energy is possible, like sustainability studies for reusing and recycling of materials? Like he wants to know, like plastic, if it can be reused, can we apply sustainability studies there?
I think it kind of goes into the idea of the circular economy, and when we look at keeping things in this continuous loop. Now, if you look at plastics, you can keep recycling them, not all plastics. So some thin plastic bags, for example, are hard to be recycled, but bottles and different forms of plastics can be readily recycled. It's when you keep recycling them over and over and over again, actually the quality of the material starts to degrade, and it gets to a certain point where you can no longer recycle the plastic, or you have to have some virgin material added to that process to improve the quality again. So yes, you can keep recycling, but ultimately you do need to reuse or re-add new material at some point. So what we're kind of pushing towards, rather than recycling, because it does use a lot of energy to recycle the plastics, it's better to reuse the plastic directly. So have plastics that are durable, that can last for a long time. Have like a plastic water bottle that's like a solid water bottle that you can keep refilling and refilling, or have Tupperware to keep your food in it, for example, that you can keep reusing. There's even some stores now that serve, you can get your groceries with just plastic boxes. You don't have to have any packaging and things anymore. So it's looking at how can we eliminate single-use plastics and keep reusing durable plastics within our day-to-day lives and in industry. So I hope that answers the question, kind of.
Okay, there is an interesting question here. Can sustainability only be feasible if it's cost effective? If so, would it be more economical to wait for sustainable changes to be affordable, or would it be more ethical and better for the environment to make sustainable changes right away?
This is a good question. So it's a question we face a lot in the industry, and we sometimes face a lot of resistance in applying a sustainability method, because the client says it's too expensive, it's too it's going to cost me too much, I don't want to invest in this, and that's a lot of resistance that we do face. However, as sustainability consultants and in the industry, you have to sell the business case of why it's important to become more sustainable, and it's not just from an economic perspective, but most of the time you can argue that economically in the long run it is definitely the better option to choose a more sustainable option, and that's mostly because either it's client, or a developer, or whoever it may be, sometimes has a tunnel vision where they're just looking at that upfront investment. They're not always considering the long-term life span of that material. So a classic example is they looking at the energy consumption in a building. Now, clients don't want to install a really fancy, sustainable, efficient system because it's expensive. But if they do, the operating costs and the money that they will save in making that process more sustainable in the long run outweighs the upfront costs that they need to do for that investment. So that's one way to look at it, look at the full life cycle, the life cost of it. The other way, and this is where governments play a key role in supporting, is through government laws and regulations that actually have to push industry into being more sustainable, because it becomes law, it becomes, you cannot make a process and get away with doing it in an unenvironmentally friendly way, because the government is there adding law, but they're also supporting the manufacturers and industry to transition. So it's a bit of both support from the government and also long-term thinking.
Okay. The next question, is a master's degree in sustainability important?
For me, I find the master's degree that I did was very eye-opening. It was it was a good stepping stone into the industry, because the colleagues that I had in my cohort were very passionate about sustainability. So it really gave a good motivational boost, you could say, into entering sustainability industry, because you're working with everyone around you is wanting to be in sustainability. It's not necessarily a prerequisite. I think you can go into sustainability if you're already in industry, or if you enter with just the bachelor's degree, you can still enter the sustainability industry and work towards improving the industry practices. But I do think the masters can help to show your commitment and your knowledge to future employers on your interests in sustainability, and it helps to add that extra bit of value that maybe others may not have if they're just entering with a bachelor's.
Okay. Next question is from Akshay. What are your views on nuclear energy, and what do you think about UAE's move towards nuclear power?
Okay. I think so. Nuclear energy is perhaps a stepping stone towards sustainable form of energy. I wouldn't classify it as a sustainable energy form now because of the nuclear waste that's produced, and we're some years away yet from creating a fission process where you don't have any nuclear waste. So it's going to be some time in the future that we can actually create sustainable nuclear energy, but I think it can be used as a stepping stone to reduce CO2 emissions, but I don't think it should be the only option. I think it's great that UAE are diversifying their grids, their energy grids, so that they are not just reliant on gas, and it gives more security as well to the grid because they have a different source of energy. But I think that in the long run, it shouldn't be the only option to look at sustainable forms of energy, because if we keep going nuclear, in 100 years' time, we're going to have run out of space for where to put the nuclear waste. So it plays a role, but it's not the answer at this stage.
Okay. The next question is something related to the current situation. It's from Dr. Vandana. So how sustainability is going to help during the pandemic situation?
Sorry, could you
I think she refers to COVID-19 pandemic situation. Yeah.
How sustainability will be impacted by COVID? situation. Yeah.
Yeah.
So I think the impact of Corona, it's had some positive impacts when we look at sustainability, particularly around air pollution. So if you look at air pollution across different parts of the world during the lockdown, you could see huge improvements in air quality. And particularly even in Dubai, I had a review of some of the air quality data here and noticed that compared to years before, it's actually quite improved. So that's obviously one aspect, but then we don't want to lock everyone down for months and months on end. So that's not something that we can do in the long run, but it really does show that, having what the impact lockdowns can have on improving air quality, and also it really highlighted how much we necessarily don't need to travel that often. So now that countries are opening up and people are starting to work more and travel more, we've realised we can do a lot of work from home, so you no longer need to commute to your office. We can take holidays, staycations. We don't need to necessarily fly away to a different country every time we go on holiday, and therefore reduce emissions associated with air travel. So I think in terms of our own personal emissions, we've perhaps realised that, by working from home, by taking less holidays, we can actually cut down on our emissions that we produce, but we can still live good quality lives. So I think that's kind of been a reflection of the COVID situation. Moving forward, do we always need to fly so much? Do we need to travel as much as we do?
There is one quite interesting question. This question comes to my mind also many times. So avoid, minimize, and if needed, generate. AMG concept. How important can this concept be for sustainability, and how important it is to be understood by everyone? Avoid, minimize, and if needed, generate.
So I think it's an interesting one because it really changes from country to country in different cultures, how much we consume, how much we purchase. Everything that we buy in our day-to-day lives has embodied emissions associated with it, and often people don't realise the carbon footprint of their products that they have. People that are buying, clothes or a new car, a new house, whatever it may be, each of those products has emissions associated with it. So I think the way to make it understood by more people should be that every time you buy something, you have the carbon emissions. So simply like when you get your energy bill from DY, you see how many carbon emissions your energy is associated with. If you buy a new product, say a mobile phone or a laptop, you should have not just the price, but also the carbon emissions that the product contains. And I think that would help people recognise how much impact that their products are having on the environment. And we often, don't see the environmental impacts of a lot of the things that we do, purely because we're not outside in the field, or we're very tunnel vision to just seeing the end product. We don't see the full process behind it. So having more informative information that can show us what this product manufacturing is having, I think can help people to make more informed choices about the products that they purchase.
Okay, we have a nice question from Praveen. If it's a small company, maybe he means it's a startup company or the one with a little bit of investment. If they care about sustainability and environmental impact, then how does it make profit? Means how the investment is going to be profitable?
If they're only focused on environmental products. So you'd be surprised that actually differentiating yourself as a small company and producing a product that is sustainable, there is a big market now towards people purchasing more sustainable products. So you will find that actually it can be a unique selling point in some untapped industries where there isn't not a lot of sustainability or sustainable products. If you are managing to differentiate yourself in that sector, you can actually generate a lot of profits because you know, either government legislation, you know, people in general who are looking to purchase more sustainable goods. There's a lot of drivers now that are actually impacting people's thought choice when they look at their supply chain of what they want to purchase. So if you are a small company producing something in an environmentally friendly way, it might be more expensive initially, but you can stand out in the fields of your product in that way.
Okay, I hope that answers this question. Now, something similar. Given that pro-sustainability government policies increase operational costs, not every company can afford sustainability. Do you think that chemical engineers will be crucial in designing sustainable and cost-effective plant designs that will also conform to the policies of the individual nations? And would chemical engineers play a big role here?
Yes, would definitely agree that chemical engineers have a big role to play when it comes to changing the way processes are made. You may think that whatever chemical or production line that you're involved in that is actually at the most sustainable or most efficient way currently, but often it's just because that's the way things have always been done and things haven't changed. There hasn't been anyone driving sustainability in that industry. So especially young graduates, they're entering chemical engineering, they have that new fresh lens where they can look at this process and identify where are the inefficiencies, where can they make improvements, where can they ultimately reduce the carbon footprint of the end product. And often a lot of companies haven't conducted that full, the life cycle assessment that I was discussing before. There's many products that haven't gone through that process yet, and chemical engineers have the opportunity to really look at their full process and make the changes. So definitely they have a big role to play in improving processes. And then with regards to the government's policies that increase the operational costs. In some cases that may happen, but tends to be when government adds in some policy, there's usually some incentive along with it to help support companies make that transition. So that they're not falling behind or they're not faced with financial difficulty. So in most cases there is ways to do that, but the best way to do it is to become more sustainable before these policies come in place. So you're already ahead of the game.
Okay. Now, like this avoid, minimize and generate concept, is the corporate world taking any initiatives to promote this concept currently?
Corporate world, I would say it depends on, again, company to companies vary. But the concept of avoiding, minimizing from a waste perspective, particularly, we see in a lot of corporate offices now, they have recycling stations where they can recycle paper, or there's even in our office, for example, we have signs that say do not print paper unless it's needed. So from that small perspective, in corporate office environments there is, but in a larger corporate company that's perhaps manufacturing a product, it's less probably utilized in the sense that they actually can't avoid making the product in the first place. It's part of their business model. So there we look more into how can we make that process more streamlined and avoid where possible using certain materials, but if they need to be used, how can we then reuse waste in the process, recycle waste, or completely eliminate the generation of waste. So looking at the supply chain and saying, making sure that they order, for example, exact number of products that they need or materials that they need, so they don't over order, they don't have wastage in their process. I hope that answers the question.
Yeah. Any more questions?
I hope all the questions are asked and answered.
Thank you, ma'am. Thank you so much. That was an interactive question and answer session.
Yeah.
Faiz, I think you can take over.
Thank you, ma'am, for the Q&A session. I would request Mr. Siddharth to deliver a vote of thanks.
Hi. So I'd like to thank you for coming out to this event and giving this talk. I'm sure it must be a very, very hectic schedule, given like what time and place we are as of now. So that we are extremely grateful for that. And to have someone in the heart of a sustainability industry like the Middle East is something definitely new to us. And I think that also adds a lot more dimension to the subject as itself. So we're extremely happy to have someone like a company which is a towering figure in the Middle East come to this event and just give us all the information we need to hopefully pursue something in sustainability. So finally, I'd like to conclude by thanking Mr. Abdul Azad from the Career Services, Dr. Jason, the academic president, Dr. S.K. Pandey, the chairperson, and my chemical engineering faculty as well, Dr. Vandana ma'am and Shobha ma'am, for being the moderator for the questionnaires, and finally my classmates for organizing and putting this together. So thank you so much, and I hope it's been very informative for everyone.
Thank you very much for having me. I really appreciate it. It's been great to speak to you all today and to answer some of your questions and give you an insight in sustainability. So yeah, good luck to all the students on their chemical engineering course. I remember I was there just a few years back. I know it's a very, very tough degree. It's a lot of work, but I'm sure you'll all do really well. So good luck to everyone in the rest of their course. Thank you.